Good morning, student. Here we are learning chapter number 12, Heron's formula, and it is part number 3. Now, we have learned that how can we find the area of a triangle by using the Heron's formula. Now, using the Heron's formula, we are going to find the area of any quadrilaterals. Now, here we know that in a triangle there are three sides. So by that way, using the semi-perimeter, we have the formula square root under square root s into s minus a, s minus b, and s minus c. So by this way we can find the area of triangle. Now about the area of quadrilaterals. Area of a quadrilateral, how can we find it? So just we know that if we draw any quadrilateral A, B, C and D, if we draw any quadrilateral A, B, C, D, and if we draw diagonal of this quadrilateral BD, so BD divides this quadrilateral into triangles. What you can see here, it divides the given quadrilateral in two triangles. So now we first find the area of this triangle and area of after then area of this second triangle. So after getting the both area of the triangle, we just take addition of both area, so we can find the area of given quadrilateral. So let's consider some examples. Here given example number 5. Students of a school staged a rally for cleanliness campaign. They walked through the lines in two groups. One group walked through the lines A, B, as you can see here, A, B, B, C, and C, A, while the other through AC, CD, and DA. Then they cleaned the area enclosed within their lines. Means whenever they walked, then the inclined area they have cleaned. If AB is equal to 9, BC is equal to 40, CD is equal to 15, DA is equal to 28, and angle B is 90. Which group cleaned more area and by how much? Find the total area cleaned by the students, neglecting the width of the lines. So that here given that ABC one triangle and ADC another triangle, we want to find the area using the Heron's formula, but we first have to find the AC. So that how can we find the AC? As we know that ABC, as you can see here, ABC is a right triangle. It is right triangle. So by using Pythagoras theorem, we can find AC. So after that we have all this side, then we can easily find the area of both triangles. So since AB is equal to 9, BC is equal to 40 meter, angle B is equal to 19, we have AC is equal to square root of 9 square plus 40 square meter, which is equal to square root 81 plus 1600 meter, which is equal to square root 1681 meter, which is equal to 41 meter. So we have AC is equal to 41 meter. So now we have all the sides of these two triangles. So we can find the area. Here in a right angle triangle, you can use height into base to find this area. Therefore, the first group has to clean area of triangle ABC, which is right angle. So area of right angle ABC is equal to half base into height, which is equal to half into 40 into 9 meter square, which is 180 meter square. So it is area that is cleaned by group A. Now let in the second group has to clean the area of triangle ACD, which is scalene having sides 41 meter, 15 meter and 28 meter. So let semi perimeter is equal to 41 plus 15 plus 28 divided by 2, which is equal to 42 meter. So by Heron's formula, area of triangle ACD is equal to square root s minus a, s minus b, s minus c, 41 into 42 minus 40, sorry 42 into 42 minus 41, 42 minus 15, 42 minus 28. So hence we can find 162 meter square as a area of ACD cleaned by second group. So first group cleaned 180 meter square, which is 180 minus 160 meter square, that is 54 meter square more than the area cleaned by the group. The total area cleaned by the all students, that is 180 plus 160, 126, which is equal to 306 meter square. So by this way, by such way that we can find the area of given quadrilateral. Now let example number 6. Sanya has a piece of land which is in the shape of rhombus. In rhombus we know that all sides are equals. She wants her one daughter and one son to work on the land and produce different crops. She divided the land in two equal parts. Two equal parts. As we know that the diagonal of rhombus divides the rhombus in two equal quadrilaterals. If the perimeter of the land is 400 meter and one of the diagonal is 160 meter, how much area each of them will get for the crops? So let here you can see that the given ABCD field, it is a rhombus and its perimeter is 400. Then we know that the perimeter of rhombus is 4L. So by that way, each side is equal to 4 meter divided by 4, because all sides are equal. So perimeter divided by 4 sides, which is equal to 100 meter. So each side is of 100 meter. That is AB is equal to AD is equal to 100 meter. Let diagonal BD is equal to 160. Then semi perimeter of the triangle ABD is given by S is equal to 100 plus 100 plus 160 upon 2, which is equal to 180 meter. So let us using the Heron's formula. Therefore, area of triangle ABD is equal to square root of 180 into 190 minus 100, 180 minus 100, 180 minus 160. Square root 180, 80, 80 and 20 square, which is equal to 4800 meter square. So therefore, each of them will get an area of 4800 meter square. Alternate method also you can use, that is draw CE perpendicular to BD. It is one, if you draw AC, the one another diagonal, then we know that the in rhombus both the diagonal intersect at 90 degree. It intersect both both are perpendicular bisector. So it bisects in equal two parts and perpendicular to each other. So draw CE perpendicular to BD, as you can see here. As BD is equal to 160 meter, we have DE. DE will be 80 meter, because CE is a perpendicular on BD and it divides in equal two parts. So it will be 80. And DE square plus CE square is, which is equal to DC square, which gives CE is equal to square root under square root DC square minus DE square. So CE is equal to square root of 100 square minus 80 square, which is equal to 60 meter. So hence we have CE 60 meter. So therefore the area of triangle BDC, height into base, half of height into base, that is one half 160 into 1 into 60, which is equal to 4800 meters square. So by this way we can also find that. Now let's solve some example from the exercise number 12.2. Question number 4. A triangle and a parallelogram have the same base. What is given that? A triangle and a parallelogram have the same base and the same area. Both have same base and same area. If the sides of the triangle are 26 meter, 28 meter and 30 centimeter, and the parallel stands on the base 28 centimeter, find the height of the parallelograms. Now we know that if you want to find the area of a triangle, as here given all the sides, so we can easily find, we can use Heron's formula. So we can find the area of triangle, and its area is equal to parallelogram, and the area of parallelogram is given by height into base, and here base is given because both are on same base. So and given that both have same area, so comparing the both area we can find its height. So let the solution. Here you can see in the figure parallelogram ABCD and triangle ABE. ABE is and parallelogram ABCD stand on same base AB with 28 centimeter its length, and all triangle have all side here, as you can see here, A is equal to 30 centimeter and BE is equal to 26 centimeter. So first we find the area of this triangle and compare with parallelogram. In the figure, ABCD is the parallelogram and ABE is the triangle which stands on the base AB. For the triangle AB, A is equal to 30 centimeter, B is equal to 28 centimeter, C is equal to 26 centimeter. Therefore, S is equal to A plus B plus C by 2 is equal to 30 plus 28 plus 26 by 2 centimeter, which is equal to 42 centimeter. So the area of triangle AB is equal to square root of S minus A, S minus B, S minus C. Put the value 42 square under root 42 square, 42 minus 30, 42 minus 28 and 42 minus 26 centimeter square. Hence, which is equal to square root of 42 into 12 into 14 into 16 centimeter square, which is equal to under square root of 1128.96 centimeters square, which is the square of 336 centimeter square. Now area of the parallelogram is the base into height, and we know that area of parallelogram is equal to area of triangle. So we put 336, which is equal to 28 into height, given area of triangle is equal to area of parallelogram, is, as we know that. So height of the parallelogram is equal to 336 upon 28 centimeter, which is equal to 12 centimeter. So by this way also we can find the such things which is unknown. So by this way you can solve some examples from the exercise 12.2. There are given question number 1 and 2. Solve it by yourself, and if you find any doubt then you can discuss it with me.